Wait. The energy in the previous module. Oh my god. Pathetic formula. Well, if you are tired of that formula, let me present you the 10 times the formula in this module. And all thanks to my binding energy. An awesome concept, a brilliant concept. What is binding energy? And wait, what is that? Ionization? What is that energy? Let's take an example. I am a nucleus. I'm a nucleus. And my fist is my electron. Now, I have bounded this electron to me. That means I've kidnapped it. And I'm telling, if anyone pays me 1 lakh rupees, I'll release the electron. So people are like, 1 lakh? Sarkar, 5,000 hai. And I'm like, no. Minimum I need 1 lakh rupees. Then only I'll free this electron. So binding energy is that energy supplied to the nucleus or to the electron so that the evil nucleus releases it. The minimum energy. That's binding energy. So why is the name ionization given? Now imagine I am an atom. And if you are an atom, okay? And if somebody takes your electron, you become Vidwa. That Vidwa atom is called ion. So the energy with which an atom becomes a Vidwa, that is called an ion, that's called ionization energy. So the whole idea is, therefore it must receive energy equal to negative total energy. Why negative? Why B is equal to minus of T? See, you are supplying me the energy, I'm taking it. Okay? You are trying to pull off the electron, I'm to pull in. We both are opposite. You are total energy, I'm binding energy. Or you are binding energy, I'm total energy. Whatever it is, we both are opposite, aren't we? That's why there is a negative sign. Negative sign simply means that you have to provide me. Electron says, मैं इतना अभाव हूँ. अभाव मतलब deficit. Deficit मतलब deficiency. You need that kind of energy to get liberated. So, I'm pretty much sure you must have looked at that formula that irritates me still. Me raised to 4 upon 8 epsilon 0 square, n square, h square, that was a formula of total energy, but it was with negative sign. But because binding energy is equal to minus of total energy, this is the formula you have in front of you. And of course the cloud, which we have done in the last module, you know. Ladies and gentlemen, I'd like to present to you the awesome table. Get your pen pencil ready because the first parameter we'll study is the kinetic energy. What is the formula with respect to R? E square upon 8 pi epsilon 0 k into 1 by R. Please remember this. So what is the relation with R? It's inversely proportional to R. As simple as that. And you also remember that if we put the value of R, what we get is me raised to 4 upon 8 epsilon 0 square h square into 1 by n square. So your k is inversely proportional to n square. Simple. The beauty is, look at the potential energy. Just look. Look. Don't look at me. Disappear me. Okay. Wow. Whoa. What I can see is, look at kinetic energy with respect to R and potential energy. Only difference is instead of 8, that is 4. And in the next column also you will see the same thing. Instead of 8, that is 4. And of course there is a minus sign in potential energy. And when you look at the total energy, ladies and gentlemen, you will be baffled with joy and happiness because total energy and kinetic energy formula is one and the same. There is only difference of negative sign. And the ultimate part is the binding energy. Look at binding energy formula. Whoa. And if you compare it with the total energy, you already know they both are negative. And binding bolo, ionization bolo, it's one and the same. So I like to present to you the series of formula which almost means one and the same thing. That's called energy. So here I developed a King's formula. A relation. There's no such thing as King's formula. I just give the name. The formula is kinetic is same as total but negative sign. And it's half of potential but with negative sign. So numerically, kinetic and binding are same, only numerically. Okay, just to remember for the formula, which is same as ionization. Through this formula, you can solve any sum. And the best part is he's formulated 6 formulas. No, just by remembering 2 formulas, you formulated 12 formulas. Congratulations. But now let's come towards the another part of MCQs or the entrance part. That is, as electron makes a transition from excited to ground state, from higher to lower orbit, what happens? Kinetic energy, potential and total energy decreases. Kinetic energy decreases, potential energy increases, but total energy remains same. Kinetic energy and total energy decreases, but potential energy increases. If kinetic energy increases, but potential energy, my goodness. As an electron makes a transition, always remember, okay, from excited state to the ground state of an atom, it comes towards the nucleus. The force of attraction increases, the velocity increases, kinetic energy increases. But kinetic is opposite to total, so total energy decreases. Even kinetic is negative of potential, potential energy decreases. So when it goes from higher to lower orbit, what happens to kinetic energy? Increases, potential decreases, total decreases. Oh, that was just an MCQ for you. Now, as electron make a transition from excited to ground state, your kinetic energy is this formula. Wow. What is Z? Z is atomic number. So it is inversely proportional to n square. We know that. U is potential energy. Again, it is inversely proportional to minus of n square. And total energy is inversely proportional to minus of n square. That means what happens to your number of orbit decreases. Kinetic energy increases. Potential energy decreases. Total energy decreases. That's the spirit of the energy, and I hope you understood each and every concept of energy of electrons. Stay tuned.